Okay, let's give you guys some more practice. So now we are on Mercury. Gravity on Mercury is 3.7 meters per second squared. We're going to fire a cannonball at 60 meters per second at an angle of 84. We are on top of a hill which is 40 meters high. Find out the range. Okay, so do what you have to do, find out the range. So press pause and have a go. Okay, so as usual, break this bit up. Okay, so the vertical component would be this, horizontal component would be this. Jump to your velocity time graph, and it should look like this. Maximum height is here. This point here is this point here. Okay, and this point here, the landing point, would be here. Okay, well, anyway, your velocity time graph will look like this. The equation for this line here, is this. So at the maximum height, the velocity would be 0. So put the 0 into this v here. So this equation here becomes this. Okay, and then work backwards to find out the time it takes to get to the maximum height. So the time it takes to get to maximum height is blah 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 here. So this is the time it takes to get to the maximum height. And so your velocity time graph now looks like this. The initial vertical velocity is this. The time it takes to get from here to here is given by this. So the area underneath the velocity time graph represents the distance traveled. Or so basically this this times this here, and then divided by 2. Okay, that will give you the area of this triangle here. So the maximum height is this thing here, which is this, and then times the across here, which is this. Okay, and then you cut it in half. Okay, divide by 2. So this here, well, tidy this up now. So basically, this thing here becomes this, and sorry, hang on. This thing here becomes this thing here, and then you divide by 2. And when you divide a fraction here, it gets multiplied to the bottom, so it becomes this. Okay. If I'm going too fast for you, then watch the previous video. I took it step by step then. So now the maximum height is given by this. Punch this into your calculator, it will give you this. So this figure here actually represents the actual maximum height. So far the maximum height here is actually this height here. The height the height of the maximum height is given by this here. Because we're on top of a hill, we've got to add the two together. So the overall height here, okay, the overall height will be this plus this, which is 521.17. Okay, so the overall height is 521.17 because we've got to get this height here added to this height here. So that will give us 521.17. Now imagine you are standing on top of a building, which happens to be 521.17 meters. So now drop a cannonball. When anything's free falling, you've got to jump to this formula here. So put this into the age. Find out the time it takes for the cannonball to hit the ground. Okay, so blah 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 here. It takes 16.78 seconds to hit the ground. Okay, so on the way up, it takes 16.13 seconds to get to the maximum height, and then on the way down, it takes 16.78 seconds. But you see, these two figures are very similar, but our diagram here, if you look at the diagram, it should take about, something here doesn't make sense because it takes 16 to go up here, and then it takes 16 slightly longer. So what's gone wrong? Well, not so much wrong, but the way I've drawn the diagram is badly drawn, because what it should look like here, you see, this height, what it should look like is more like this. the hill is actually just 40. Was it 40? I can't remember. The height of the hill is 40. But when you shoot the cannonball up here, it actually travels a lot higher than the way I drew it. So it should go all the way up here. It should go all the way even much higher than this, and then down here. Um, but the way I've drawn it, well, it was badly drawn basically. So hang on. So when you come to work out this, and then you get this figure being similar to this figure here, it means that your diagram is not to scale. So a better, well, it's still, the diagram's still ugly, but it's this point here. My point is that this height here is only tiny. It's 40, and then well, if you look at the maximum height up here, maximum height is 400 and let's say 480. Okay, so our diagram here, well, this height here is 40 or 400 and whatever it was, it's really high up. So when you come to draw this, yeah, well, you can improve it by redrawing your diagram. So now it takes 16.13 seconds to get to the maximum height, and then it takes 16 point and slightly longer to travel to the ground. So the total flight time would be this plus this. Okay, so total flight time would be this plus this. So going up, coming down. Okay, so total flight time is this, and now jump. Well, now imagine you and your dad sitting in a car, driving it at a speed of this for 32.91 seconds. So how far would you have traveled? So basically, just get the speed times the time of flight. Well, time of flight is 32.91, and then, well, the whole range would be this. So basically, if you get the speed here times the total flight time, that will give you the range. Okay, so I'm just going to go back to the beginning and scroll down so that you can see the overall answer. So first, you break this thing up into its two components, and then jump to the velocity time graph and blah blah blah. I'm just going to scroll through these so that you can press pause on your video if you need to run through it. Okay, so it becomes that, and then your diagram looks like that, and then imagine you standing on top of a building here. Okay, and then blah 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 blah, and then blah 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 blah, and then this. So that, yeah, and then that, yeah, and then the overall answer will be this. Okay.